Hello, we're Group 1 Extrudes. Today we're going to show you GD&T for a ballpoint pen.
For our project, we chose to do a Papermate profile ballpoint pen. This pen contains 9 parts and 2 distinct stages, engaged and disengaged. When the pen is engaged, the tip is pushed out of the housing and it is able to be used to write on surfaces. When the pen is disengaged, the tip is retracted inside the housing so you do not accidentally mark on pockets or other surfaces.
So here we have an exploded view of our assembly, and as you can see, all the parts lie along the same axis. And here's our liaison diagram. The majority of the parts are rigid as they don't move, but here with the push button and the push button cover, you can see they're sliders, and that's because when you engage the pen, when you click it, these two move translationally up and down only. And then we also have the ballpoint bearing itself, which is connected to the ballpoint tip, and it's held there. However, it can still rotate. So it stays in the same place, but rotates to allow ink to go through. And then with the ink tube, it's connected to the push button with a pin. So about that, it can turn. However, since it's rigid to everything else, you don't see any rotation.
So this is the barrel of our pen. The main purpose of this is to house the different components that we've designed. So this includes the spring, the ink container, the cap, as well as the grip. It gives the pen a lot of form and structural support. As for the GD&T, we've applied circularity here at the end so that it can sit flush with the cap. And additionally, we gave a profile surface to the helical sweep, which is used as a screw, so that the cap can fit into it and fit snugly. And finally, we did a straightness of the axis along the entire barrel so that all the components can fit into the barrel, as well as make it easier for a person to hold. So this is the ink tube. The function of it is to hold in the ink so that you can eventually write with it. And we've applied only a singular geometric tolerance to it, and that is circularity. And this main purpose of this is to make sure that the pen tip sits snugly inside.
All right. So here we have the cap, and the main function of it is to keep the position of the push button and push button cover either engaged or disengaged, hold everything inside of the pen, spring, ink tube, all of that, and also provide a nice way to hold on to the pen with a clip that can just go in your pocket. And the way it connects is through these sweeps here. It screws onto the cuts on the inside of the barrel. So to achieve this, we needed a couple of necessary GD&Ts. The first is the straightness of its axis. That way nothing is warped and it can just fit into the barrel nicely. Another one that's necessary is for the helical sweep, that we have a profile surface, and that way the extrusions here can match up with the cuts on the inside of the barrel. Finally, we also need circularity of the outside dimension that goes inside the barrel. And this way we can control whether or not it's too big and it actually fit inside the barrel. And finally here we have the cross section, and with the cross section you can see so when the pen is disengaged, the push button cover and push button itself are resting up here. And when it is engaged, the push button cover are down here. And that way, that moves the ink tube in and out of the barrel. So here we have the ballpoint tip, and its purpose is to bring ink from the ink tube to the ballpoint bearing. And the way it connects to the ink tube is it just fits inside of it snugly. To achieve this, we need a couple of tolerances for it. First of all, we need cylindricity, and that ensures that the diameter of the tip fits inside of the ink tube. Next, we also need straightness to make sure that the tip itself is not curved in any way along its axis. And also, very important are these angles here. So we need an angularity of the conical tips, and these make sure that, one, the ink has enough room to flow to the ballpoint bearing, and also the ballpoint bearing is held in place as well. And finally, circularity of the diameter of the conical tip is important, so the ballpoint bearing can be held in place as well. So here we have the ballpoint bearing, and what this does is when it's pressed against the paper or whatever writing surface, it rotates and allows ink to flow from the tip. You only need one tolerancing on this. We got to control its profile, its surface, to ensure it's a perfect sphere and can fit snugly into the tip.
The push button is important to keep the ink tube engaged. It achieves this by rotating about its axis and using its teeth as pointed by the green arrow to lock into certain slots of the cap. The angularity is important on the teeth so that it can achieve contact with the push button cover. And the straightness of the axis is important to fit into the cap and fit into the push button cover. The push button cover is a smooth surface for the user to disengage and engage the pin. Their exterior protrusions are used to fit into slots and limit rotation about the center axis. And the bottom teeth are used to make contact with the push button in order to engage the pin. The angularity of the teeth are important to make smooth contact with the push button, and the straightness of the axis is important for it to fit into the cap.
This is the grip. It is a rubber object used as a sleeve around the barrel. Its main purpose is to provide friction between the user's hand and the pen. This is so that the user's hand does not slip while writing with the pen. The surface of the grip is important that it be identical no matter which orientation, so the user feels the same surface no matter which way the pen is facing. The spring provides a constant force on the pen to keep it in whatever state it is currently in. This is so that the pen does not accidentally toggle without the user's intentions. Whenever the user intends to toggle the pen, they will push on the spring in order to change it. The straightness of the spring is important so that it fits snugly around the ink tube and does not slip.
To finish off this presentation, we wanted to share a bit about what we got out of this entire process. To start off, we learned to advance our modeling technique, as designing each individual part made us become more and more comfortable with modeling in Creo. Next, we learned to implement GD&T on necessary components, as not all parts need to be toleranced geometrically. After that, we learned to create a coherent drawing, as at the end of the day, we're not always going to be there to explain what our drawings mean. So it needs to be comprehensive so other people can figure it out. And finally, we learned how a pen works.